All right, let's start working with some data. So here's the first problem that we're going to do. We're going to calculate the expected returns and standard deviation of expected returns for both assets X and asset Z. So assume that we have three different economic states: a recession, a normal economic state, and an expansionary state, and we have probabilities that are given of those economic states occurring. For instance, there's a 15% chance of a recession, 55% chance of having a normal economic activity, and 30% chance of having an expansionary economic activity for some period in the future. Let's also assume that stock X let's assume that stock X will have negative 2% returns if there is a recession, 15% returns if there's normal economic activity, and 29% if there's expansionary. And the returns across the different economic states for stock Z are also discussed. So the first question is which formulas do we use? Do we use the expected return or the mean return? Do we use the standard deviation of expected returns or the sample standard deviation? Anytime you see that a probability is given, right? Anytime you see that a probability is given, we know that we can use the expected return or the standard deviation of expected returns. So we're going to use the left formulas here, the expected return and the standard deviation of expected returns here. Okay. So what I've done over here in Excel is I've just replicated the table that I've provided as part of the problem. And then what we're going to do is I'm going to calculate the expected return for stock X, the expected return for stock Y, or Z rather, and then I'm going to calculate the standard deviation or sigma of stock X and sigma of stock Y of Z. I don't know why I keep saying Y. Okay? So I'm going to do this in Excel, and you're going to be able to see as I work through it how I'm using the formula on the left-hand side of your screen to do this. So I'm going to calculate the expected return. I'm going to multiply the probability of the jth state, or in this case the first state, times the return for that stock in that state. And I'm going to do that for each of the economic states, and I'm going to sum across the economic states. Or I'm going to write the following formula. The expected return for stock X is equal to the probability of the first state times the returns to stock X in that first economic state plus the probability of the second economic state times the returns to stock X in that second economic state plus the probability of the third economic state times the returns to stock X in that third state. What I've done is I've just calculated the weighted average, where the weights are the probabilities of the different economic states occurring. When I hit enter, I get a return of 16.65%. Let me format this and put that in percent so it's consistent with the percent returns. Okay. And that's intuitive. That should make sense. Look, in a normal state, there's a 55% chance. It's about 15%. I know that my average is going to be around there somewhere. I lose 17% when I go from a normal to a recessionary state, and I gain about 14% when I go from a normal to an expansionary state. I could have almost guessed what that expected return is going to be. Let's calculate the expected return for stock Z. Again, what I'm going to do is I'm going to take the probability of the first economic state occurring, follow the formula here, the probability of the first state times the return in that state for stock Z, plus the probability of the second economic state times the return to stock Z in that second state, plus the probability of the third state times the return to stock Z in that third state. And I get a return of 10.4%. Format that as a percentage. 10.4%. I'm also going to quickly format these as percentages too. Does that make sense? So that formula looks a little tricky, but it's just taking the weighted average, where the weights are the probabilities of the different economic states. Now to calculate the standard deviation of expected returns, it's going to require a little bit more. Okay, so I'm just going to follow this formula. I'm going to say equals the square root, and I'm going to open up parentheses. And I'm going to take the probability of the first economic state, and I'm going to times that by the squared difference between the returns for stock X in that state and the mean return. Let's do that. So I'm going to take the probability of the first state times the returns for stock X in that first state minus the expected return that we just calculated, and I'm going to raise it to the second power or square it. Does that make sense? So I just followed that formula, and now I have to add across the different economic states, or sum across the states. So I'm going to add the probability of the second economic state times the returns for stock X in that state minus the expected return that we just calculated squared plus the probability of the third economic state times the squared difference between the returns in that state for stock X and the expected return. And I have to close my square root parentheses there, so I'm going to take the square root of that big long formula inside of there, and when I hit enter, I get a standard deviation of stock X of 9.97%. Okay. I'm going to calculate the standard deviation of expected returns for stock Z as well, the same way, square root. Take the probability of the first economic state occurring times the squared difference between the returns for stock Z and the expected return of stock Z squared plus the probability of the second economic state times the returns to stock Z in that second state minus expected returns for stock Z that we just calculated, square it, plus the probability of the third economic state times the squared difference between the returns to stock Z in that state and the expected returns, square it, close my parentheses, and I get a standard deviation of only 2.62%. So a couple things to notice here. Stock X has a much higher expected return than stock Z, but it also is much riskier, 9.97% versus 2.62%. All right. So that's how we would use these formulas when calculating the expected return and the standard deviation of expected returns for these assets.